Hey guys, welcome back to hashincludeelectronics with another video. And in this video, we are going to make parallel parking car model using ESP32 module. We will turn the wheels of the car using servo motors for easier parallel parking. We will use transmitter created using analog joystick and ESP32 board to send car control commands. Transmitter and receiver ESP32 modules will communicate using ESPNOW protocol. So let's get started and make this car. If you haven't subscribed yet, please hit subscribe button below and press bell icon to get latest updates. Let's first make the transmitter. We will need ESP32 module, analog joystick, 5V DC supply, or we can use any power bank, breadboard, double-sided tape, and few jumper wires. Let's make a connection as per circuit diagram for transmitter. First, mount ESP32 board on breadboard. Attach joystick using double-sided tape on breadboard. Connect joystick to ESP32 pins now. First, we need to get MAC address of receiver ESP32 module. For that, connect receiver ESP32 board to laptop. And upload this get MAC address code. Select ESP32 rover module and port. Hit upload. Once uploaded, open serial monitor and press enable button on ESP32 module. You can see that the MAC address is printed. Note this down because we will use it in the code. Let's take a look at transmitter code now. Inside transmitter code, first we need to include the ESPNOW and Wi-Fi library. Then we have defined pins for X and Y axis and also defined pin for switch. Then we have set the receiver MAC address as found in the previous step. We have defined message data structure to send data. We have defined on data send callback function which will be called when data is sent using ESPNOW protocol. Inside setup function, initialize the ESPNOW. Now register the callback function. Then we need to set up the receiver peer info and add it to ESPNOW. Set switch pin as input pull-up. Inside loop function, read the X and Y axis value. Read the switch value and see if it is pressed. If switch is pressed, then its value will be low. We will use this flag to rotate the servo motors during parallel parking. Now we will send the data through ESPNOW using ESPNOW send function. We will add some delay for data to be sent. The code link is provided in the description below. You can upload it directly. Connect transmitter ESP32 module to laptop using USB cable. Select ESP32 rover module and port. Hit upload. Now let's take a look at receiver. We will need 4 TT gear motors, 4 wheels, 4 servo motors, wooden plate for car chassis, ESP32 module, L298 and motor driver module, UBC to provide 5V to all servo motors. You can also use any buck converter. 7 to 12V DC battery, in our case LiPo 3S battery which will provide enough current, glue gun and few jumper wires. Let's assemble the car now. First, let's solder wires to gear motors. Mount all 4 motors on car chassis using glue gun. Fix the plastic connectors to all servo motors and screw it properly. Attach DC gear motors to servos now. Make sure these are aligned properly. Join red to red and black to black wires of DC motors on each side. Attach L298 motor driver module on car chassis using double-sided tape. Fix ESP32 module on car chassis using double-sided tape. Let's make a connection as per circuit diagram. Connect L298N motor driver module to ESP32 pins as per table. Attach DC battery power connectors to motor driver module to plus 12 volt pin and ground pin. Connect UBC to 12 volt supply. Now provide 5 volt and ground to all servo motors from UBC 5 volt output. We are providing separate 5 volt 3 ampere supply to servo motors through UBC. UBC is used to step down battery voltage to 5 volt. Connect right side motors to out 1 and out 2 pins of L298N motor driver module. Now connect left side motors to out 3 and out 4 pins of motor driver module. Connect all servo motor signal pins to ESP32 module. We will take plus 5 volt and ground from L298N motor driver module and provide to ESP32 module through 5 volt and ground pin. Attach wheels to car now. Let's take a look at receiver code now. First we need to install ESP32 board using Arduino board manager. I have provided the ESP32 board link in the description below. Go to File, Preferences and add the ESP32 board link. Then go to Tools, then Boards Manager and search for ESP32 and install it. Now we need to install ESP32 servo library as well for servo motor control. Go to Tools and then Manage Library. Search for ESP32 servo and install it. Now we need to include the ESPNOW and Wi-Fi library. Also we need to include ESP32 servo library. We have defined pins for all 4 servo motors. Also created objects for controlling servos. We have assigned the right and left motor pins. We have defined max motor speed as 200. Its max value can be 255. You can change this as per your requirement. We have set the PWM frequency resolution and channel for speed. We have created message data structure to store the received value. We have park car flag variable to check if servos to be rotated for parking. We have on data receive callback function which will be called when ESP32 receives data. Inside this function we will check if switch is pressed. If pressed, then we will rotate the servos based on park car flag. You can adjust the servo angles to reverse the servo rotation if needed. Then based on X and Y axis values we will rotate the car. X and Y axis values will vary from 0 to 4095. Y axis value is used to rotate the car in forward or backward direction. X axis value is used to rotate the car in left or right direction. We have created rotate motor function which takes right and left motor speed as argument. It will rotate motor in forward or backward direction. Then we have created park car function which will rotate the servo positions. We have created setup pin mode functions to set motor pins as output. Also set the PWM channel for speed control. We will attach the servo pins to servo objects. Initially set servo positions to 90 degree. Inside setup function we will call setup pin mode function. Then init ESPNOW. It will set up callback function as on data receive. We can keep loop function empty. I have provided the link to the code in the description below. You can upload it directly. Now let's upload the code. Connect ESP32 module to laptop using USB cable. Select ESP32 rover module and port. Hit upload. Now connect battery to car. This is the front of the car. This is right side and this is left side. Provide 5 volt supply using power bank and USB cable. That's it. Let's see how it works. As you can see, car is controlled using joystick. If you press the joystick switch, then wheels are turned 90 degrees for easier parallel parking. We need to remember following points. We need to provide proper power supply to this car. Make sure to provide separate 5V power supply to servos. Hope you guys enjoyed the video and thanks for watching. Stay safe and please like, share, comment and don't forget to subscribe to my channel.